Our aim is to turn an arbitrary process for the prescription of rigid ankle-foot orthoses, or AFOs, into a scientific method which is objective and standardized and ultimately leads to better clinical effectiveness and cost effectiveness. Across the UK, there are about 90,000 AFOs prescribed every year, and we know that their clinical effectiveness depends on them having adequate rigidity. However, AFOs are still prescribed and produced based on anecdotal evidence and historical practice, and without any real scientific, objective guidance on how to control rigidity. This often leads to suboptimal structures and poor patient outcomes, or require a remake of the AFO, which delays treatment and costs the NHS financially. We then have the added issue of a lack of standardization in manufacturing. Thus, when a clinician requests an AFO made to a specific thickness and with specific reinforcing elements, 10 different technicians will provide 10 different devices, while the same technician will never produce an identical device twice. To address these challenges, we are mapping the variability in current clinical practice with regards to prescription, design and manufacturing of rigid AFOs. At the same time, we are also using mechanical testing and computer modeling to quantify and for the first time fully assess the effect of design and manufacturing parameters on AFO rigidity. The insight on optimal AFO design and the realities around AFO provision will inform the co-creation of objective guidelines for the production of optimum AFOs. To ensure efficacy and clinical applicability, these guidelines will be co-created with frontline clinicians, technicians and service managers from every aspect of AFO provision, as well as with users of AFOs. Successful completion of this project will lead to practical and clinically applicable guidelines that A. help clinicians to reliably prescribe optimal AFOs, and B. support technicians to reliably produce optimal AFOs. This will mean that people affected by debilitating bone, joint or muscle conditions requiring rigid AFOs will experience fewer delays in treatment, improved clinical outcomes and better quality of life. The NHS will benefit from reduced costs and reduced clinical and administrative burden of duplicate AFOs. Last but not least, successful completion of this research will open the way to expand the concepts, methods and tools developed here beyond rigid AFOs to other orthotic devices. We would like to thank Orthopedic Research UK, who is supporting this study, and we hope that we can make a difference to global orthotic service provision.